Hi there, my name is Philip. Welcome to Chemistry Class Notes. So today we're going to be looking at the Neco chemistry, question on the SWOT analysis. That's number 2 questions on the practical, which is going to be I think 21st of October. So this is just like a guide to the SWOT analysis part of your chemistry practical Neco question. So from the specimen I was given, the source there was iron 2 chloride. So I've drawn up some questions, surrounding that particular SWOT. So like what I did here, the first thing here, this C is representing the SWOT, right? And so most times the first step will be you should add a certain quantity of water, maybe 5 ml or 10 ml of water, of distilled water rather, to the SWOT. Then you record the observation and inference. So this first part I said C plus distilled water. Then you know that of course iron 2 chloride is soluble in water. So I said C dissolves to form a pale green solution. You can see this is a pale green solution. Then the inference is that since it dissolves, the difference here would be C is soluble. So also add said plus litmus paper. Iron 2 chloride is made up of a strong acid and a weak base, and so you expect the strong acid to have an overriding effect over the weak base. So FeCl2. From that formula, you can sense that it is formed from iron hydrochloric acid and a metallic base, that is iron hydroxide, and so you expect it to be acidic. And so when you test it with litmus paper, that is this solution now, you expect blue litmus paper turn to red. So that will indicate that the SWOT is acidic. So here I said C is acidic. Then normally you might be asked to now divide this solution into 3 portions, because you're going to carry out this separate analysis on them. So here I said first portion, that is assuming that you're going to say, okay, measure 5 ml each of this portion into maybe 3 or 4 test tubes. So I'm saying first portion plus sodium hydroxide in drops plus SS. When you add sodium hydroxide to this solution, you will expect a dark green precipitate. So I'm saying a dark green precipitate formed. That is in drops. But when I put SS, there is no change. I said no visible change. So the inference here would be Fe2 present. Then under this test now, if the mixture is left to stand for some minutes, you will notice that the precipitate will turn brown. Why? Because the iron 2 will be oxidized by air to iron 3. So iron 3 is brown, right? And iron 2 is green. And so I said precipitate turned brown. It is oxidized by air to Fe3 plus, that's iron 2. That means oxidized from iron 2 to iron 3. because as you leave it in the test tube to stand for some time, the air, of course, the oxygen around there will now, oxidize iron 2 to iron 3, and so the precipitate will turn to brown. Remember, I said these are likely, questions. Is to guide you. I'm not saying that it's going to come out exactly the way it is, but this should guide you on the kind of things to expect. Then, second portion plus aqueous ammonia in drops and in excess. Normally the reactions with of the salt with sodium hydroxide or aqueous ammonia, will give similar reactions. Here we say dirty green. Some they will say dark green, dirty green. The most important thing there is the color. Is the color change that is taking place and the fact that precipitate is formed. Don't be confused by, at times you hear dirty green precipitate or dark green gelatinous precipitate. The most important thing is the color. So for ammonia, aqueous ammonia, a dirty green precipitate is formed. In excess, no visible change or no reaction, right? Or precipitate remains insoluble. So all these are words that can be used in place of no change. You now see no visible change or precipitate remains insoluble. So the same inference here will be the same as for sodium hydroxide. So I'm saying iron 2 ions present. Then coming here, part of what we were given in the specimen was this compound, hexacyanoferrite 3 ion. This compound is to confirm the presence of iron 2. And so when you add aqueous solution of this complex compound called potassium hexacyanoferrite 2, potassium hexacyanoferrite 3, is going to react with, the solution containing, that iron 2 to form either you can say a dark or a deep blue precipitate formed. That is when this complex reacts with solution containing iron 2. And so the inference here would be iron 2 plus confirmed. Note, this compound is to confirm the presence of iron 2. You either say a dark blue precipitate formed or a deep blue precipitate formed. And of course, we have confirmed that yes, that the particular salt contains iron 2. Then lastly, I also added this one, like third portion plus dilute HNO3 or HCl, as the case may be, plus silver nitrate solution. We expect a white precipitate to be formed and Cl minus present. Then when you now add excess of aqueous ammonia, the precipitate dissolves, and when that happens, you can confirm that yes, the salt also contains chloride ions, which will be fitting because what we were given was iron 2 chloride. So it's going to be the end of the small video on salt analysis, your Neco chemistry questions that should be coming up on the 21st of this month. Remember, this is to guide you. At least it's not. I'm not saying that these are all the questions that you're going to see that day, but you can go through this to prepare you, for your questions out there. Remember, you also have to go and prepare on the first question there, which is on titration, and the other questions. So if you enjoyed the video, you can leave a like and subscribe. Thank you.